This tutorial, I'm setting up a DappNode enabled device and installing a Gnosischain Validator. So DappNode is an open source project that makes easy packages for deploying and hosting DApps, P2P clients and blockchain nodes. It's a great, easy to use platform that makes the process of installing and setting up nodes such as Ethereum or Gnosischain a few clicks. In this tutorial, we're going to be setting up a validator for Gnosischain. To do this requires setting up an execution client, a consensus client, and a validator client. These are all different software packages with specific functions. The software clients need to be configured correctly and set to communicate with each other, and the setup process is quite technical normally, but with DappNode, the setup is super easy and convenient with simple downloadable packages, but still gives you the full control over your node without any centralized intermediaries. So what is DappNode? DappNode Core is basically a software platform that can be installed on most hardware. This is a really great interface to interact with node software packages. The Dapp Store, the Dapp Store hosts a library of packages for DApps, nodes that can be accessed via the DappNode Core software. And we can have a look and see what's available here. There's quite a lot to choose from. And there's also the DappNode Store, which has pre-configured, pre-built devices, making the setup that much easier if you wanted to just obtain ready-made hardware to get going instantly. First steps is either install DappNode Core on your own device, or you can get a pre-built DappNode device from the store. To begin, we need to connect up. To begin, we need to connect up the DappNode device, which just means power on and connect to the internet. If you bought one of these products, it's really easy to set up. Simply power up with the Ethernet connection to your router, power on until the light's visible, and leave for about 5 minutes as it boots and connects to the LAN. After this, you can attempt connecting to the device. Which you can see the options for connecting to it here. Alternatively, if you wanted to install this on your own device, you can do so here. From the instructions, there's custom hardware installation. You can install from script, you can install from ISO package. So once we've got something set up and connected to the internet, we should attempt to connect. Connect to our DappNode. There are multiple ways to do this. I'm using the Wi-Fi to connect, which I found to be the easiest way without any problems. Find it in your Wi-Fi settings, just DappNode Wi-Fi. Password will just be lowercase DappNode. And head to this URL here, which is https my.dappnode. On first login, we're prompted to register, which is just creating a username and password to access our device, separate from the Wi-Fi login details. Once you've done this, you'll press register. You'll be given a recovery token, which you need to write down. This is if you ever lose access to your account. So we've now registered a username and a password. We just need to log on, and then we're first prompted to set up. For now, just select anything here. We'll then be prompted to change the password again. All set, and this is our dashboard. We can have a look at notifications, check for system updates. It'll also tell us that we need to change our default Wi-Fi login password, so I would recommend doing that next. You'll then need to log into your Wi-Fi again with the new details. So check for a system update. If one is available, we want to do this as well. So once that's updated, next we will be installing our packages. So head to the Dapp store. We need to install our execution client, then consensus client, first execution, and we're looking for Nethermind XDAI. Nethermind is a client implementation for the execution layer of Ethereum and Gnosischain. Right now we're looking for Nethermind XDAI, which I'm sure will change to Nethermind Gnosis in later updates. So we'll get that. We want to install. We want to enable auto updates. And we can have a look at config. This is our settings that we can change, such as ports. Logs. This will output the last 200 lines from our client. We want to see that it's started to sync, which you should see once it's finished downloading headers. It usually takes about 20 to 30 minutes. And then syncing of the execution client maybe takes around 12 hours, 24 hours, depending on your hardware. Alright, this package, just Nethermind, is actually an Ethereum full node that I set up on startup. We can either delete or pause this service. I've paused it, unless you want to utilize the Ethereum full node. You can just keep it running, but it would take up maybe 700 gig of space. It's a useful thing to have. Full node grants you independent access to the network, but if you just want the Gnosischain Validator, there's no need. I'm currently running one on another device, so it doesn't really make sense for me to run another one here. Now we are going to install our consensus client. If you search for Gnosis, you'll find consensus clients. If you search for Gnosis, you'll find consensus clients. In the description, you should have something like CL, Beacon Chain plus Validator. I'm selecting Teku for this instance. I'm already running Lighthouse, so we'll be choosing something else for client diversity, which is important for network health and decentralization. So we install that, and we're going through the setup. We have some configurations to make. Graffiti, if selected the validated block, this will be custom text of your choosing. Default is validating from DappNode, but this can be whatever you want. The Gnosischain URL, this is the RPC endpoint of your own execution layer node, which is the first package we installed, Nethermind. It's already detected and placed the address in for us. You have to run one of your own going forward. Post-merge, services like Infura and Alchemy will no longer work for beacon nodes, consensus clients, like what we're installing now. So yeah, you have to run both an execution load and a consensus client. Checkpoint, if you're setting up a beacon node, you can use a checkpoint address for a much faster sync. Yeah, and here's the address we want to use. HTTPS, it's checkpoint.gnosischain.com. Your fee recipient address. This should be your own ETH format address that you have full control of. This is where fees from transactions in blocks you get selected to validate will go. There was also the Web3 signer. Yeah, this Web3 signer. It's an extra package that will manage our key stores in a secure way. This needs to be the same client as our consensus client. So I've got Teku as we're installing Teku. We can so enable auto updates again. running both beacon chain and validator. The config, this is just the settings we've configured earlier when we installed the thing. We can head to logs, and we've got our beacon client logs and our validator client logs. Validator is what manages the validator duties such as attestations and voting on proposed blocks. We haven't uploaded any key stores yet, so logs won't show much. And we are going to be moving on to that next. Right, so at this stage we've installed both execution and consensus client. We're running these and they will be syncing, which means downloading, verifying chain data, and this will take somewhere between 12 hours depending on your hardware. If you use checkpointing for the beacon node, it probably won't take that long. The next step is generating our keys. Now we're generating our key stores. We want to head to the Gnosischain GitHub and look for the validator generator or validator data generator repository. If we scroll all the way down, we can find instructions to install. I'm using Windows. This can be done on either Mac or Linux. If you want to do this on Linux using Docker, then you can look at any of my easy guides to the Gnosis Validator, which covers that step. The method I'm using now is the easiest and quickest way to generate keys I've found. So we're looking, we want to find the latest release, and we're looking for the file which is the data generator binary, and we want to download this. And it needs to be the one correct for our operating system. In my case, Windows. So just download this. I've already downloaded it. We can use something like 7-zip to decompress and extract the binary. I've extracted it to a folder that I've put in documents here. Now we want to open the command prompt and copy the address or location of our folder as we need to work from this directory. So just cd change directory to the folder where it was extracted to, and we need to run this deposit.exe new mnemonic, but we want to add a few more arguments in this here. So on these arguments, the new mnemonic will generate a new seed. Number validators, number dash validators. This is how many validator key stores we want to run. So if you bought the DappNode package that comes with 4 GNO, then we need to create 4 key stores. You can of course create as many as you have GNO for, 1 GNO per validator. The ETH1 withdrawal address is the ETH1 format address that you are in full control of. You will need to include this, as it will, otherwise it would default to an address derived from the seed, and that may cause issues later when you come to deposit. The withdrawal address is the address where, when you initiate a withdrawal, where your stake plus your rewards will go to. So it's select your language. You'll need to enter a decrypt key, password, and your seed will be displayed. You need to secure this and store it safely. Do not store it digitally. Do not share like I've done right now. Write this down, store somewhere safe, make a backup. You'll need this to withdraw. It's the only way to recover your GNO. Once confirmed, it'll now generate your keys. So this has generated the key stores and placed them in a folder called validator keys within the working directory. next step is to upload the key stores to our Web3 signer. Back to the dashboard. Once our execution layer and consensus layer clients have finished syncing, we can upload our key stores to our validator client using a package called the Web3 signer. Here in packages, if there's an update available, just go ahead and update it. This was installed alongside our consensus layer client whenever we installed that. We need to select the same client implementation as your CL client. In my case, it's Teku. So once this is finished installing and enable auto updates again, we want to open up via the UI, which is this one here. Right, now to import, just import key stores. And here we need to navigate to our folder that contains our key stores, and we can simply drag and drop this is where we input the password. Select use same password for every file if you have this option. This is the decrypt key, or the decrypt key we used earlier when creating the key stores. Import slashing protection, have this selected. Okay, so that's successful, and you should now find your key stores under validator accounts here. There's also a link to the beacon scan explorer, but these won't show up until the deposit's being made and accepted. Right, now back to Teku. I'm just checking the logs for the validator, just having a look just to confirm that they've been detected. Unable to retrieve status is because they have not been registered in the beacon chain yet, as the deposit's not been made, nor have they been activated. In some cases, this will reflect in the logs and display something like awaiting activation, but this depends on your chosen client and version. What I wanted to confirm was added validators, which means the previous step was successful, which I saw earlier. Now back to the dashboard. We're just going to double check, ensure both clients are synced. We've checked the keys have been imported. All that's left now is to make our deposit. So making our deposit, we need to head to this URL, deposit.gnosischain.com, connecting our MetaMask, and the Gnosis Chain network needs to be selected. So if you purchase the DappNode package with the 4JNO incentive, you can use this tab. You can drag and drop your deposit data.json and then let that validate. It's checking the file. Okay, now just click through these disclaimers, but take note as it's important. If you're making the deposit yourself, this process will be slightly different. You'll need to have the required GNO in your wallet and some XDAI to pay for fees, or to pay for gas to make the transaction. But that's essentially it.